guys, welcome back to my channel. Today I'm going to talk something about limits in maths. What is limit? Limit means limit beyond which something cannot go. That's a limit. You can't go beyond that point. That becomes a limit. Okay? So in maths there is something called limits. In calculus, limit as a certain value get closer and closer to a certain value, a certain function approaches a certain limit. Limit means can't go beyond that. So it's a concept in maths, and that's what we're gonna do briefly. And it's a very exciting topic in maths, so let's do it. So I'm gonna give you something in maths which looks like, let me write it down, LIM, and I do something like this, and then give you a function like this one over this. Then I tell you find the limit of this. This thing here suggests limit as x. For example, this is actually x. As x gets closer to this number 3, this is a function. You know what's a function? This function gets closer, approaches a certain limit. Okay? So for us to find this, we'll use one or two methods. Now, these methods, one of them is called direct substitution method. In this direct substitution method, you're going to plug in a value, okay, and try to find a solution. What do you find when you plug in a value? For example, now, here, you're given x squared, and you're given that 9 over this function here. Now suppose we put here to be 3. If you square 3 and minus 9 to give you 0, and since the 3 is the value of x, we put it here also. 3 minus 3 is going to give you 0. So you see there, 0 over 0 is 0. That is what we call in maths undefined. 0 over 0 undefined. So for us to work this kind of maths, we have to plug in values which are closer to the value that we are calculating, but not exactly. So you can find a limit by plugging in a value which is closer, but not exactly 2. Now, for example, let us say this value here and this value down here, this is a function, we could give it, it's f of x. If you are familiar with this means a function of x. This is a placeholder. It could be this value inside here, any other value, f of x. So f of x, let us calculate, for example, 3.1, because if you calculate 2.9, it's going to give you a negative value, because when you square that one out, it will give you a value which is less than 9, which is this one, and if you subtract it from this, it's going to give you a negative value. So we're going to give a value slightly higher than 3, so that we cannot get a positive value. So now let's say that value here is f of 3.1, for example. So you see this has taken 3.1 as taken in place of this, right? So according to this expression you are given here, let's calculate the value. In other words, we're going to get 3.1 squared minus 9 over I'll show you in a minute. 3.1. There's people are washing things outside, so don't mind the noises. So it will give you 9.61 minus 9 over 0.1. I've already calculated it. If you do these maths, you square 3.1 minus 9, it will give you that value there. And that value is 9.61. You can subtract 9 to give you that value, which is 0.61. Okay, I've written it. I'm gonna write it. Sorry, I've not written it. 0.61 over 0.1. This is what you get if you subtract these things here and divide them over here. You're gonna get this value here, and once you divide this value, I'm gonna give you 6.1 as an answer. You see? So what happens if we plug in a value which is even closer than, for example, here we put 3.1. Let's put something which is even closer than this. And let's put, so I'm going to wrap this thing off, this one. And I put another value there. Not really everything. Okay, let me wrap this one off. Okay. Now we're going to put a value like 3.01. Instead of writing 3.1, let's write 3.01. And 0.01. Here 3.01 is here. Okay. So this would be equal to 3.01 is square 8 minus 9 over, I'm going to show you 3.01 minus 3. According to this expression, we are doing this. So we have plugged in a value which is even less than 3.10. Now we have plugged in 3.01 than the previous one. Now we're going to do the maths here. Okay, we're going to do the maths here. Once we do this maths, as usual, my board is small, but I try to squeeze this. We're going to get 0.0601 over 0.01, which is equals to 6.01. You can see, if you do the math, you plug in your calculator, you're going to get this as the answer. You can see what is happening. Now we got 6.01, unlike before when you got 6.1. So we are getting closer and closer to 6. We are approaching this limit 6 as we get closer and closer to 3. You can see that this one is getting closer to 3. You can put 3.001 again. Apply the expression, it will go even less than that. Maybe, I think the concept is clear. You can plug in even less values, and you see that as this approaches, as x approaches 3, this, as it gets closer and closer to 3, this approaches a certain limit. So it will converge to a certain number. So as we get closer and closer to 3, the limit approaches 6. If limit exists, it's going to converge to a certain value. So you can go on and on until you get up to 6, which is the limit. As you give less, closer and closer to 3, you keep giving less and less. You can see there we gave 3.1 and here we gave 3.10. Okay, and you calculate, you get this. If we give it 3.001, it will be even less and less and less until you get to 6. So that's the concept of limits. As you get closer and closer to a number, as x get closer and closer to a certain number, then the function f of x approaches a certain limit. That's now one technique which you call plugging in. You plug in a value. There's also another technique, and this technique we factor out. We can factor. Let's do that. I think I'm gonna grab everything, everything, and then we write it afresh. So let's say limit x goes to 3. Now we'll factor this expression which I've gave you before, which is x squared minus 9 over x minus 3. We're going to factor this expression, squared minus 9 over x minus 3. Right? We're going to factor this. That's the second way we can do this. So let's factor it. We'll get something like x plus 3 into x minus 3. I'll show you in a minute. Over x minus 3. Make sure you agree with me that if you do this, it's gonna give you this. You can calculate this. If you calculate this expression to give you that value, you know algebra. If you have done this, I mean, you know what is factoring. You are watching this video. So once we get into this form, so we can cancel the values. Like for example, here you can see 3 and this and that can cancel. We can cancel this and cancel that. Okay. So once we do that, we can now use direct substitution to do this. So we can replace x with the 3, for example. Now we got this, and once you do this, once you cancel here, you'll have limit as x goes to 3. Now we left, once you do the cancelling here, you are left with only this expression, which is x plus 3. So here now you can directly plug in 3. Direct substitution. So if you put 3 plus 3, it will be equal to 6. So 3 plus 3 is equal to 6. And this is the limit where it converges. That's another way we can do it. And so this 6 is the limit. Okay? So guys, you can give yourself various examples and follow this method. Like for example, what is the limit of x as x approaches 7? So you can calculate, let's calculate one more. No, we're gonna do something different because this already we have done. Let's do something a bit different. Today there's a lot of noise, guys, so you have please God put up with it. I hope it will not interfere with you getting what I'm telling you. So, or should we just stop it there? I'll give you another. We'll do another time because now I'm going to record noise instead of the maths. Sorry guys, I have to stop this video here because there's too much noise coming from outside. So please follow what I've shown you. Do the various examples and let me try to do it. So just forget about the noise. Noise is normal in a human society where people live. So limit as x approaches 7, and then you're given an expression such as this, plus, for example, 2x minus 8. Right? Sorry guys, I have to stop. The noise is becoming too much. I'll do this in the next video. So guys, thanks for watching. Please subscribe to my channel as we do more maths. For today I have to end it there because also there's rain outside. Bye for today. Bye.